All right, so you got the antidiff rules, and again, those rules are going to be on your formula sheet, but I always think you should know them off by heart. Here we go. So e to the kx, coefficient of x, which is k, becomes then normally deriving your times, and in this case it's division, so hence it's 1 on k. Similarly with the sine, same thing. Usually your times by k, so now you divide. Be careful with the sine and cosine. Derivative of sine is cosine. So when you do the antidiff of cosine, that's why it's positive. Whereas the other way around, when you derive cosine, you get negative sine. That's why when you antidiff sine, you get negative cos. Okay, so just being careful with that. What else is there? Second squared, pretty much related to tan. Everything else is the same. 1 on k is all the coefficients. Let's do the first one. All right. What's the problem? Yes, we have an exponential, which we have the rule for. The problem is it's all to the power of 2. What do we do? What do you do because you got that power of 2 there? That seems a bit of a problem. Anyone got ideas?
Expand it out.
You can, yeah.
You can just integrate the polynomial.
That's right. So if it helps, you can treat it like this is A, this is B. So A plus B squared is the same thing as A squared plus 2AB plus B squared. Because it's in the brackets, you can't just antidiff them individually. You have to split it up into separate terms. So first things first, you're going to use, let's call A equal to e to the x, and let's call B e to the negative x. So according to the rule, you are now finding the antidiff of a squared, which is e to the x squared, plus 2 times a times b, so 2 bracket e to the x times b, which is e negative x, plus b squared, which is now e to the negative x squared dx. Don't forget the delta x. If you forget it, you lose a mark. Here we go. So then from here, we know index laws says that if you have the powers in the brackets, index law number 3 says you multiply the powers together. So now let's simplify that. That becomes now e to the 2x, because x times 2 is 2x, plus 2. Now what is the next bit? How do you simplify this bit? Let's go with Joe. How do I simplify e to the x times e to the negative x? What does that become?
E to the power of 0.
E to the power of 0, because that's the same thing as when you're multiplying the same basis, add the powers. X plus negative x is 0. So e to the 0 is the same as writing 1. Very good. So that's like saying times 1 there. Okay? And then plus, this is now e to the negative 2x dx. So if I wrote it all out again, you're really just finding the antidiff of e to the 2x plus 2 plus e to the negative 2x delta x. Okay, now they're in their separate terms. You can then do them individually. You can then work out what is the antidiff of e to the 2x, antidiff of 2, and then antidiff of negative 2 to the x. So using the rules I've given you on that chart, give me what is the answer for the antidiff of e to the 2x. Let's go with Alex. What would you get? The rule's right here. Here's the rule.
You get 1 over 2
Yep.
e to the power of 2x.
Beautiful. That's it. So the k value, or the coefficient in front of x is 2. So it's 1 on k, e to the kx. Next one. What is the antidiff of 2? Let's go with Ian.
Negative half e to the power of 2.
Sorry? 2x, yes. Yes, you can think of it as this is technically x to the power of 0 at the moment. So if you use what you learnt yesterday, add the power by 1 and then divide it by n plus 1. So technically, this is just 0 plus 1. So 2 over 1 is 2, and then x to the power of 0 plus 1 is x to the power of 1 which makes sense because the derivative of 2x gets you 2, so antidiff of 2 should get you 2x. Okay? So that's another way of thinking about it, but I just think of antidiff a constant should give you a linear. Yeah? Next bit. What is the antidiff of e to the negative 2x? Let's go with Ryan. Negative half e to the negative 2x. And what are we all missing? Plus c. Very good. Okay, and again, if this is an exam, don't leave your answer with a negative power. Convert it. So it should be what? Half e to the 2x minus half again, but this time it's e to the 2x on the bottom. One of the common mistakes is students mixing the 2's and flipping everything around. It's just the negative 2 is on the e. So it should just be the exponential that flips over and plus 2x plus c. So if you like, you can combine them together, but at this moment, I'm just sort of showing you the motions of how you would have done it. Okay? All right, so that was for the first one. Example 1 had the square as a problem. What's the problem in example 2? So you got the rules for exponential. Well, what's the problem for example 2? What's the challenging thing here? Can I please have Ella? What's making this problem more challenging? Very good. This is the fraction. So your goal when you're seeing this question is how do you not make it a fraction? Break it into their individual terms. How do you break it apart? Because they both shared e to the x, you can actually write it as 3e to the 2x over ex minus 5 over e to the x. That's fine. Same denominators, and you add or subtract the numerators, so you can just split it up into 2. What's beneficial by splitting them up? Well, this one, we can simplify e to the 2x divided by e to the x. This is index laws, same bases, different powers, but when you divide them, you subtract the powers. So e to the 2x divided by e to the x, what is that, Adrian? What's e to the x divided by e to the x? E to the x, very good. So this becomes now e to the x, but don't forget you've got a 3. Actually, I should do it in black. Still have a 3. Minus, and then this one, we want to rewrite it in a way that we can use our rule. So usually it's e to the power of something. So in this case, it is, how can you rewrite this? 5 what? Let's go with Noah. Yep. So that we can use the rule. Beautiful. And then you're back to whatever rule you've got. Okay, so antidiff each one. You now know the k values. So let's antidiff then. Antidiff, what is the antiderivative of 3e to the x? Can I please have, let's go with Emily. That's right, it's still 3e to the x. Minus, what's the next one? What's the antiroot of 5e to the negative x, Albert?
Negative 1 over 5 e to the x negative.
You got the negative right, but it's not 1 over 5. Because what's the k value at the moment?
Is it not? Or is it just x over 5?
Or not x over 5? No. K value, so the rule is e to the kx, antidiff of that equals 1 on k, e to the kx. At the moment, you just need to know what k is. K is the number in front of x. Number in front of x at the moment is negative 1. So it should be 1 on negative 1, e to the negative x. But because you've got the 5 at the front, so you times them together, you should get negative 5 e to the negative x. Yeah? That's an exercise to practice. Yeah? All right, putting them all together, that gets you now 3e to the x minus a negative is plus 5e to the negative x. And don't forget plus c. Again, rewrite that without the negative powers, but this is an exercise, so likely they're okay with your answers there. But I would have flipped it and then maybe combine them together. Okay? All right, let's give you, I reckon, 4 minutes, 2 minutes each. Try example 3, example 4. Let's see if we get them correct. So you got your sine rule, cosine rule available just in front of you on your table there, but have a go with these two. I'm going to give you 4 minutes. I'm going to pause the video. Okay. Can I get a show of hands who, I think, yes. The mistake that might occur is if you forgot antidiff of sine is a negative cosine. Can I get a show of hands who had the negative? All right, good. So that's, if they chuck it in the exam, usually because they're trying to catch you on the negative. So k is 3, so it'll be 1 on 3, but there's a negative, and k is 3 there, so it's 1 on 3 as well. Putting them together, I just took out the 1/3 as a common factor, and then it's e3x minus cos of 3x plus c. Hands up, you got the correct answer. All right, well done. Next one. This one, there is just a fractional problem to see if you guys can do that. They do expect that in the exam. Again, cos becomes sine, so there's no negatives there. K is 2, so it's 1 on 2. This one's a minus there, but double negative, so make sure you didn't screw up with the sign, so it should be plus. Careful with 1 divided by 3 pi on 2. A lot of students struggle with this bit. For those who do struggle with 1 divided by 3 pi on 2, rewrite it as 1 divided by 3 pi on 2, and you're more likely to make it right. So when you divide, you do the reciprocal. So it becomes 1 times 2 pi on 3. So technically that is 2 times negative 2 pi on 3. That's how I got 4 pi on 3. What? Wait, something's wrong. No, that's all right, yeah. Oh, why did I pull the pi up? Sorry. There we go. Okay, so that's how I got that bit. And then antidiff of the constant is linear. So hence you get an x. Can I get a show of hands who got at least that fraction bit? Very good. Excellent. Flip over the next page. There's a problem solving now, so flip over the next page. I'm going to give you, same thing, 4 minutes. See if you can answer both part A and part B. Hopefully you didn't make the same mistake as I did. I thought it was at x equals 1. So the whole thing was like off when I put a 1 there. It was meant to be 0. Clearly it says that x equals to 0. Then it would have worked out nicely. Otherwise I ended up with some pretty huge cos fraction. But you should get k equals negative 4 for A. Hands up if you got k equals negative 4. Beautiful. Second part. So after you know that at x equals 0, f dash is 0, the next one is using the actual point. F of 0 should equal to negative 1. So when x equals 0, the function is equal to negative 1. So that means you can find the function by finding the antidiff. With the plus c, you can then substitute f of 0 equals 1 to then solve. So did you then get c is equal to 3?
Yes.
Okay, that sign scared me for a bit. I was wondering if I made another mistake. So c equals to 3. So f of x must then be 2 sine of 2x minus 4e to the x plus 3. And then the last part was substitute pi on 6. You should then cancel out root 3 on 2's with the 2's. And you end up with root 3 plus 3 minus 4e to the power of pi on 6. I'm going to pause that screen there in case you haven't had a go. But that's it. That's D and G. D and G is just getting you to familiarize with the rules and apply calculus that you already know. So I'm going to stop the video there. Here we go.